This is a video to review 5.3 concepts. In 5.3, we learned how to find domain, and we also learned how to name different Lewis structures with their electron geometry name and their molecular geometry name. We're first going to learn how to find domain. So domain is consisted of two parts. All right, you have one, which is your attached atoms, and then two, which is your lone pairs. A thing to consider is that single, double, or triple bonds always count as just one bond or one part of your domain. So when you look at this example on to the left, we have water over here. So we want to figure out how many total domains we have. So the first thing that we're going to look at is our bonds. We always want to look at our central atom. So our central atom in this case is here. You can see that water has two bonds, each bonded to a hydrogen, and it also has two pairs of lone pairs. So our total domain is going to be 4. The next example in the middle, when we're looking at phosphorus, our total bonds is going to equate to 4 because we want to remember that double bonds only count as 1. It does not have any lone pairs on the central atom, so therefore our total domain is 4. In the last example, our central atom is carbon. You can see that carbon has 3 bonds coming out of it because double bonds count as 1. Therefore, it has no lone pairs, so we're going to write 0. The total domain is going to be 3. Once we figure out how to find our total domain, we can draw Lewis structures and we can actually start naming them. So we're going to do our first example, which is SF6. So we're going to put sulfur in the middle, and we have 6 fluorines coming out of our sulfur. Every sulfur molecule has 6 valence electrons, so we can put 6 over here. Each fluorine also has 7. So we can put our valence electrons for our fluorine all around. They don't really play a role in our domain, but there they are. So now, each sulfur is going to bond with a fluorine, so it's going to look like this. Perfect. So sulfur is an example of an expanded octet. All right. When we try to figure out our total domain for sulfur, the total domain is going to be 6, right? Because it has no lone pairs, but it has 6 bonds around it. So now we want to figure out what our electron pair name is. So we're going to look at our chart. You're going to have this chart during the test. So we're going to look at our domain section, and we're going to go all the way down to domain 6. All right? Because it has 6 domains around it, our electron pair name is octahedral. So you can write that down. Octahedral. The next thing that we want to do is figure out our molecular geometry name. So now, in this case, since we have 6 total domains, we have no lone pairs, the molecular name is also going to be the same, and we're going to write octahedral for that. The next example we have right here on the right is H2CO. So when you draw your Lewis structure for H2CO, carbon has 4 valence electrons, so you can draw them in. Each hydrogen has 1, and oxygen is going to have 6. All right, this is going to bond here, this is going to bond, and then this is going to bond, and then you're going to take this electron and you're going to move it here. So we're going to form a double bond right over there. All right, our central atom in this case is going to be our carbon. Right, when we try to figure out the total domain, we can see that carbon doesn't have any lone pairs, but it also has 3 total domains coming up at it. And therefore, our electron pair name is going to be trigonal planar, and then because it has no lone pairs, our molecular name is also going to be trigonal planar. The only difference is what if you have lone pairs? When you have lone pairs in your Lewis structures, you want to look at the general formula. All right, A stands for a central atom, X is the number of bonds, and then an E is how many pairs of electrons you have. I hope this helps. If you still need help, please look at your 5.3 notes and then let me know.